Hello everyone. Uh, I am Dr. Chander Pawar, working as Associate Professor in the Department of Chemistry at Marri Laxman Reddy Institute of Technology. Today we will be discussing about remaining part of our second module, and that is nothing but battery chemistry and corrosion. Last time we were discussing about battery chemistry, primary batteries, secondary batteries, and the lithium ion battery. What is happening, what is the mechanism during discharging and charging, and thereafter now today we will be discussing briefly about, yeah, here these are the references we can see for the battery chemistry. Engineering chemistry by PC Jain, and engineering chemistry by Ramadevi, and a textbook of engineering chemistry by Tirumalachari, and textbook of engineering chemistry by Jayasri Ani Reddy, and engineering chemistry by Sika Agarwal. These are some of the references. Now today we will be discussing about fuel cells. Okay, so basically this module 2 is categorized into two types. Part A is battery chemistry and part B is corrosion. So now extensions to battery chemistry, there are fuel cells, basically electrochemical cells, followed by the fuel cells and solar cells. After completing this part 1, we will be moving to part 2, that is nothing but corrosion. So now let us see what is fuel cell. Okay, first in 1838 Sir William Groove invented these fuel cells. Okay, when it is invented, 1838. Okay, and fuel cells are electrochemical cells consisting of two electrodes, nothing but anode and cathode, an electrolyte which convert the chemical energy of chemical reaction between fuel and oxidant directly into electrical energy. Now basically we all know that electrochemical cell is nothing but conversion of chemical energy into electrical energy. Okay, so battery, when we talk about battery, it's a energy storage device followed by the conversion of chemical energy into electrical energy. That is the working principle of battery. Now fuel cell is also having two electrodes. Those electrodes are nothing but cathode and anode. Now there will be an electrolyte which converts the chemical energy of chemical reaction between fuel and oxidants. Okay, so now let us see how to understand this. What is fuel and oxidant? Here you can see, in first case, fuel with oxygen goes under the combustion followed by the release of heat energy. Okay, now let us try to understand what is combustion. Combustion is nothing but something burning inside the machinery. It could be bike engine, it could be car engine. So whatever the petrol or fuel, petrol, diesel going into the machinery, the engine of bike engine or car engine, that will be, there will be a ignition and that there will be a combustion. So basically we should try to understand the two words burning, words burning and combustion. Both are not same. Though both are ultimately giving the energy, burning which is happening externally, it's an external process with the help of oxygen, environmental oxygen, burning is taking place, which is an external process. Whereas combustion, it is happening inside the machinery. Okay, so fuel is burning inside the machinery, that's why we are calling it combustion. Okay, so fuel with the help of oxygen, combustion takes place and heat energy is released. That is in the ordinary fuel cell process. Whereas in specific fuel cell, fuel with oxygen goes oxidation. Instead of combustion, it goes oxidation. Oxidation reduction, we know what oxidation is. Loss of electron is oxidation. Reduction is gain of electron is reduction. So now fuel with the help of atmospheric oxygen, it is going under the oxidation. Oxidation means loss of electron, release of electron. So Once whatever the electron released at the oxidation, that will be combined with cathodic part and reduction takes place, followed by the electricity generation. That is the basic difference between an ordinary fuel cell and general fuel cell. Okay. Now here we can see hydrogen oxygen fuel cell. We call it as HER, hydrogen evolution reaction. This is one of the best example for the fuel cell. Now see here, anode is there, cathode is there. This is the cathode, this is the anode. What's happening? At anode, oxidation takes place. At anode, oxidation takes place. Oxidation is nothing but loss of electron. Loss of electron. Okay. Now see, what is the reaction here? 2H2 gives rise to 4H plus 4 electron. This is the reaction which is taking place at oxidation. Oxidation, that is nothing but anodic part. What happened? 2 hydrogens gone into oxidation at anode part, 4 H plus ions and 4 electrons release. That means H2 hydrogen lost its 4 electrons. Loss of electron is oxidation. So whatever the electron released at anode, that will be further helping us to make a circuit like this in between anode and cathode. But whatever the protons released at anode during the oxidation, those are directly reaching to the cathode through this electrolytic membrane. Here we can see this is the electrolytic membrane which is separating the anode and cathode parts. So whatever the H plus ions generated here, those are flowing from anode part to cathode part. Okay. Whereas electrons are not directly flowing from anode to cathode. See, whatever the electron here it is ejected or released during the oxidation, that is helping us to make a circuit in between anode and cathode. Okay. समझ में? All right. Now, so once these H plus ion and electrons reach to the cathode, whatever the atmospheric oxygen is there at the cathode part, cathode chamber, that oxygen will be taking these protons and electrons which are generated during the oxidation at anode. So oxygen is taking those protons and electrons, and finally H2O formation takes place. Now hydrogen oxygen fuel cell. Hydrogen, initially we are taking the gas, hydrogen gas. Oxygen, it is coming from the atmosphere. So hydrogen, taken hydrogen and atmospheric oxygen going into the oxidation and reduction, followed by the release of H plus ions and electrons. H plus ions are directly moving towards cathode, whereas electrons are helping us to make a circuit between anode and cathode. That is final output from the hydrogen oxygen fuel cell. What's happening? Whatever the electron ejected at the anode part, that is reaching to the cathode part. While reaching the cathode part, it is making a circuit, and that circuit is helping us to energy evolution. That is nothing but hydrogen evolution, hydrogen energy evolution. So this is the basic principle of hydrogen oxygen fuel cell. Now here, what are the applications of hydrogen oxygen fuel cells? Simply these hydrogen oxygen fuel cells are written as HOFC. Yeah, here These hydrogen oxygen fuel cell used in military applications. These hydrogen oxygen fuel cells used in electronic power sources in space vehicles. These hydrogen oxygen fuel cells used in large scale power production. There are many applications of these hydrogen oxygen fuel cells, but mainly military applications, spacecraft applications, and large scale energy production. Energy is nothing but power production. These are some of the applications of hydrogen oxygen fuel cell. Now let us see what are the major differences between battery and fuel cell. In last class we were discussing about battery, and just now we have discussed about fuel cell. Let us quickly summarize what are the differences between battery and fuel cell. So battery, they store energy in the form of chemical energy. Fuel cell, they cannot store energy in the form of fuel cells. Fuel cell converts chemical energy into electrical energy, as we discussed earlier, oxidation followed by the reduction, formation of a circuit through electron exchange from anode to cathode. Reactants are inside the cell itself in the battery, whereas reactants for chemical reaction are supplied continuously from externally. Okay. Chemical reaction products remain inside the cell itself. Chemical reaction products removed from the cell itself. And batteries are rechargeable. Not all the batteries, secondary batteries are rechargeable. Primary batteries are not rechargeable. Whereas fuel cells cannot recharged. And continuously we have to supply the reactants. It could be hydrogen, it could be oxygen, it could be electrolyte. We need to continuously supply externally. These are not rechargeable. Batteries are less efficiency, whereas fuel cells are high efficiency, more energy. It consists of limited amount of fuel and oxidant, and these reactants diminish with time. Yes, consumption is taking place. If it is a rechargeable reaction, oxidation, reversible reaction, then reactant to product, product to reactant, there will be a cyclic process. But if it is a non-reversible or irreversible, then it needs continuous supply. So fuel cells needs continuous supply. Why? Because it is not reversible. Supply energy for limited period of time. Yeah, if it is a primary, then limited period of time we have to supply. If it is a reversible reaction, then no need to supply. Okay. Supply energy for long period of time in the fuel cells. And batteries are less expensive, and fuel cells are more expensive. Okay. Now, what are the examples? Battery, lithium ion battery, which we use in our mobile phones. Charging, discharging, continuous cyclic process. So lithium ion battery is the best example for the batteries. And hydrogen oxygen fuel cell is the best example for the fuel cells. Okay. These are the major differences between battery and fuel cells. Now, let us quickly go through solar cells. Solar related to sun. Okay. Solar cell is photovoltaic device that convert the light energy which comes from sun into electrical energy. This device works on principle called photovoltaic effect. Okay. Now, what is the photovoltaic effect? Let us see here. There will be a N-type silicon semiconductor which we are considering for emission, and we are calling it N-type silicon semiconductor as a emitter. There is a P-type silicon semiconductor. We are calling it as a base or substrate. Whatever the gap between N-type silicon semiconductor and P-type silicon semiconductor, that is called as PN junction. It is something like sandwich. So whenever the sunlight falls on the top of this N-type silicon semiconductor, okay, that will be trying to absorb this, n-type silicon semiconductor trying to absorb whatever the photon fallen from on the surface. That absorbed photon will be further helping us to make this p-n junction, and after this p-n junction, those photons will be reaching to the substrate, and this phenomena helping us to carry the holes, exchange of electrons between carriers and holes, and finally there will be a output, that is nothing but electricity. समझ में आया? Initially what is happening? Sunlight is falling on the n-type silicon substrate, that will be completely absorbed by the n-type silicon substrate. Whatever the absorbed photon is there, that is light energy is there, that is passing to p-type silicon semiconductor, and it is helping to form a p-n junction. This p-n junction, whatever the electron exchange from the n-type to p-type is happening, that effect we are calling it as a photovoltaic effect, and this photovoltaic effect further helping us to move or flow the holes and carriers. Finally energy will be generated. Now all solar panels will be looking like bluish color, dark bluish color. Why? Because these solar panel are bluish in color to avoid loss of photon. There should not be any reflection, or there should not be any energy loss. Whatever the sunlight fallen on this bluish panel, that photon should be completely absorbed. That is why some sodium polymer based coating will be done on the solar panels to avoid the loss of photon. Okay. Now solar cells and fuel cells, differences between fuel cell and solar cell. Solar cells and fuel cells are two different technologies that generate electricity through different processes. Solar cells convert sunlight into electricity through photovoltaic effect, whereas fuel cells generate electricity through the chemical reaction between hydrogen and oxygen, as we have discussed earlier. Hydrogen oxygen fuel cell, oxidation reduction both takes place at anode cathode, followed by the circuit formation, and then finally output energy. Solar cells require sunlight to operate. Without sunlight, solar cells cannot be functioning. Fuel cells require fuel as a source. It could be hydrogen fuel, it could be oxygen as a fuel, it could be electrolyte as a fuel. Okay. So fuel cells required fuel as a source. Solar cells required sunlight as a source. Okay. Now what are the advantages of solar cells? Solar panels should be clean and non-polluting. It is a renewable energy, environmentally eco-friendly. Solar cells do not produce noise and they are totally silent, eco-friendly. They require very little maintenance. Solar cells have long lifetime, durability is more. There is no fuel cost or fuel supply problems. Okay. These are the advantages with the solar cells. Now let us see some of the disadvantages. Disadvantages. Number one, if there is a bad weather, cloudy, no sunlight, no sunlight means no energy. No energy or solar panels are not working. Second disadvantage, To fix the solar cell panels, it needs large surface, large area. And third disadvantage is, as it is mentioned here, advantage, it should be clean. If the solar panel is dusty or dirt, the photovoltaic effect doesn't happen and energy will be not generated through these solar cells. So these are all advantages, but certainly there are disadvantages with the solar cells. What are those? Bad weather. Bad weather means there is no sunlight, means no photovoltaic effect. No photovoltaic effect means no energy from the solar cells. And they need large surface area to fix. And if the solar panel surface is dusty or having some dirt, the photon or sunlight won't be absorbed properly and it won't be working efficiently. So these are some of the disadvantages. Now let us see what are the applications of solar cells. Domestic power supply. Yes, we all know that some of the roofs, house roofs, our living homes roofs are fixed with these solar panels, and whatever the energy generated we are using for our house domestic purpose. Electric power generation is in space. Yeah, the solar cells helps us in the production of solar energy in the space. Drying agricultural products. Solar pumps used for water supply. Water heaters, geysers and these, all those. Generating electrical power easily. To provide electrical power to satellites. These are some of the applications of solar cells. Okay. Now, next topic is corrosion. What is corrosion? Corrosion is nothing but degradation or deterioration of a metal. What is written here? Definition of corrosion: decay of material is nothing but corrosion. Especially here, material is nothing but metal. Okay. Metal degradation, nothing but corrosion. How metal degradation is happening? Metal degradation is happening due to their interaction with environment, especially water, that is nothing but moisture and atmospheric oxygen. Why metals are getting the corrosion? Why they are corroded? They are corroded due to the environmental factors. What are those environmental factors? Moisture. Moisture is nothing but H2O, water, and atmospheric oxygen. So, for the corrosion of any metal, who is the main culprit? Environmental factors such as water and oxygen. These are the two main culprits for the getting corrosion of a metal. Now, what is the formula of corrosion? Fe2O3NH2O. This is the rust. Rust or corrosion. Corrosion. In Telugu we call it as a tuppu. Okay. So you can see here pictures. A chain, nut, bolt, gear, all these are corroded. Corroded means what happens? After few years or few days, that will be damaged. Okay, and we have to replace with the new machinery. Okay, so this is the formula: ferrous oxide Fe2O3, ferrous oxide with n number of hydrated aqua molecules. N represents, it could be 1 aqua molecule, it could be 2 aqua molecules, it could be 3 aqua molecules. or 4, 5, 6, n number of hydrated molecules. Why? Because rust is always in the form of moisture. Okay, that's why here water molecule. And rust is nothing but Fe2O3 ferrous oxide with NH2O. That is the formula of rust. Now, here we can see story. In the year 1988, a 19-year-old Boeing flight, which is operated by Aloha Airlines, lost a major portion of upper fuselage in full flight, which is flying at 24,000 feet height. Why? What could be the reason? Reason could be the corroded parts. The roof of that flight might have corroded, and since it is flying at 24,000 feet height, due to that pressure conditions, that top of this flight might have flew away. So main reason here for that kind of damage is corrosion. Okay. Now, corrosion is the natural conversion of refined metal to a more solid form, such as oxide form, hydroxide form, sulfide form, which causing the substance to deteriorate. Deterioration is nothing but degradation. Okay. Now, what are the causes and effects of corrosion? Includes, let us see, exposure of metal to air. Air is nothing but atmospheric oxygen, and gases like carbon dioxide, sulfur trioxide, etc. These are all harmful gases to the metal. Not only the oxygen, carbon dioxide, sulfur dioxide, sulfur trioxide, all these gases are affecting the metal to deteriorate or to degrade. That is one thing. Exposure of metal to moisture. Moisture is nothing but here H2O, water. See, corrosion is mainly because of the two factors. That is one thing, exposure to moisture, that is nothing but water. Second thing, exposure to atmospheric oxygen. Okay. Oxygen, it is in the form of carbon dioxide, sulfur trioxide gases, or oxygen, direct oxygen contact. Second factor is moisture. Moisture is nothing but water. These are the two main culprits. Atmospheric oxygen and water is the main culprits to damage the iron through corrosion. Presence of impurities like salts, NaCl, sodium chloride. If any metal is more exposed to salts like NaCl, then definitely that metal is getting corrosion. Now, temperature. An increase in the temperature increase the corrosion. Yes. For example, here in Hyderabad, the normal room temperature is somewhere 25 degrees centigrade. Whereas in the Dubai or any other Gulf countries, it is somewhere 60 degrees centigrade. If you put a metal, same metal here in Hyderabad and another same material in Dubai, which one corrodes first? Dubai, whichever we placed in Dubai, that will corrode first. Why? Because Dubai temperature is sometimes more than 60. Whereas Hyderabad temperature is never exceeds 40 degrees centigrades. So, more the temperature, more the corrosion, or faster the corrosion rates. Okay. Now, basically, metals are coming from the ore. Ore is nothing but crude form. We will be doing some processing, and finally we are getting the pure metal. Okay. Here, areas affected by corrosion, where not, wherever the metal is there, that area will be affected by the corrosion. For example, infrastructure, buildings, towers, etc. Transportation, roads, bridges, tunnels, railways, automotive, etc. Communication system, towers, etc. Raw materials including metallurgy, recycling, oil, gas sectors, etc. Energy systems like fossil fuels, nuclear fuels, biomass, etc. Food sector, agriculture sector, food production sector, etc. Health sector including implants and other surgical materials. Where not? Everywhere metal is there. Metal involvement is there means definitely there will be a exposure to atmosphere. Exposure to atmosphere means definitely it catches the corrosion if we don't take the prevention methods. Now, there are three different theories of corrosion. What are those? Acid theory of corrosion, dry or chemical corrosion, galvanic or wet or electrochemical corrosion. Here, don't confuse. Dry corrosion is nothing but chemical corrosion, whereas galvanic corrosion is nothing but wet corrosion. Wet corrosion is nothing but electrochemical corrosion. Why we are calling this galvanic corrosion as a wet corrosion? As a wet corrosion, as a electrochemical corrosion. Why? Because it is something like when we take two dissimilar metals, iron and brass for example. Oxidation reduction takes place with the help of a medium, electrolyte. It could be electrolyte, or any atmospheric medium. So galvanic cell oxidation reduction takes place with the help of medium. Medium is nothing but electrolyte. Electrolyte. So similarly here, this process is happening in wet condition. Wet condition, that could be medium, atmospheric moisture. That is why we are calling it as a galvanic or wet or electrochemical corrosion. Okay. Now, let us see what is chemical corrosion or dry corrosion. Don't confuse. Dry corrosion is nothing but chemical corrosion. According to this dry corrosion theory, corrosion on the surface of metal is due to direct reaction of atmospheric gases like oxygen, O2, halogens, fluorine, chlorine, bromine, iodine, etc. Oxides of sulfur, sulfur dioxide, sulfur trioxide, etc. Oxides of nitrogen, hydrogen sulfide, H2S, and fumes of chemicals like metal. Now, try to understand why we are calling this chemical corrosion as a dry corrosion, because there is no direct any moisture or water contact with the metal. Corrosion taking place with the help of gases. It is oxygen, halogens like fluorine, chlorine, bromine, iodine, oxides like sulfur dioxide, sulfur trioxide, nitrogen oxide, hydrogen sulfide. There is no water, only oxygen and sulfur nitrogen oxides. That is why we are calling it as a dry corrosion. There is no direct water or moisture involvement for the corrosion formation. The extent of corrosion of a particular metal depends on chemical affinity of the metal towards the reactive gases. Yes, that's true. Faster the affinity of metal with oxygen, faster the corrosion rate. Faster the metal affinity with hydrogen sulfide or sulfur dioxide or sulfur trioxide, the corrosion rate will be more. Now, oxygen is mainly responsible for the corrosion of most metallic materials. So, who is the main culprit? O2, oxygen is the main culprit for most of the metals to corrode. Substances when compared to other gases are chemicals. So, for example, there is a metal which is exposed to chlorine gas and another metal exposed to direct atmospheric oxygen. Which one corrodes first? Chlorine contact or oxygen contact? The metal which contacted with oxygen, that will be corroded fastly rather than the chlorine metal contact. Okay. This dry corrosion is of again three types. Oxidation corrosion, that is nothing but reaction with oxygen. Corrosion by other gases like carbon dioxide, sulfur dioxide, sulfur trioxide. Liquid metal corrosion. So dry corrosion is of three types. What are those? Oxidation corrosion by reaction with oxygen, corrosion with other gases like carbon dioxide, sulfur trioxide, and corrosion by liquid metal. Let us see in detail about this. Oxidation corrosion with the help of only oxygen. So corrosion due to atmospheric oxygen. Now, some of the metals directly react with oxygen in the absence of moisture. There is no moisture involvement for the corrosion formation. So who is the main culprit here? Only atmospheric oxygen is the main culprit for the corrosion of a metal. Alkali and alkaline earth metals react with oxygen at room temperature and form corresponding oxides, while some metals react with oxygen at higher temperatures. Okay. Metals like silver, Ag, Au, gold, Arum, Pt, platinum are not oxidized as they are noble metals. Don't confuse with Nobel. Nobel is related to Nobel Prize. Noble, Noble, noble. Adarsha Vayu, noble gases, helium, neon, argon, krypton, xenon. So similarly here, this silver, gold, platinum are called as noble metals, not noble metals. What are those metals? These noble metals, Noble, noble metals. So these noble metals are inert, they never carry oxidation. Why? What could be the reason? The octet electronic configuration or valence cell of these metals is completely filled. That is nothing but octet rule. When we talk about octet rule, the outermost cell should be filled with complete electrons. That means that metal will be called as inert metal. That's why silver, gold, platinum are inert metals. They are calling as a noble metals. They are shiny all the time. They won't get affected by atmospheric oxygen or moisture, and they will be shiny all the time. That's why this silver, gold, platinum has become very expensive metals to make the jewelry and ornaments. It's a huge economical business because of the inertness of these metals. Okay, now basically here we can see the reaction of this corrosion. What is happening? Fe iron goes to oxidation, Fe2 plus 2 electrons release. This is oxidation. Whatever the electron here ejected or lost by this iron, this electron will be gained by the cathode part, that is nothing but reduction. Here we see whatever the electron generated in the oxidation, okay, this electron is taken by the reduction reaction. Here atmospheric oxygen, atmospheric moisture and oxidation ejected electron, they are forming OH minus ion, that is reduction. Reduction is nothing but gain of electron. Here whatever the oxidation electron is there released, that has been gained here, and OH minus hydroxyl ion is formed. So oxidation loss of electron, reduction gain of electron. So here it is loss of electron, Fe gives rise to Fe2 plus and 2 electrons, loss of electron. Whatever the loss of electron is there, that has been gained here, oxygen with water and electron gives rise to OH minus hydroxyl ion. So finally from these two reaction, oxidation and reduction reaction, 2Fe plus oxygen, atmospheric moisture give rise to FeOH taken twice. This is nothing but ferrous hydroxide. What is this? Ferrous, ferrous hydroxide. Ferrous hydroxide. FeOH taken twice, ferrous hydroxide. This ferrous hydroxide for the oxygen and atmospheric moisture, it is giving FeOH taken twice, which is in the reddish brown color. This will be further dissociated into FeOH taken thrice gives rise to Fe2O3 NH2O. This is nothing but rust or corrosion. Okay. Now, what are the units of corrosion? Miles per year, MPY. Millimeter per year, MMPY. Milligram per square decimeter per day, MDD. And inches per year, IPY. So, why miles and millimeters, milligrams, inches it is mentioned? Because corrosion is a prolonged process. Slowly it will be taking and it is spreading like a cancer, and finally it will degrade the metal. So that's why units are miles per year. Sometimes metals takes several years to corrode. That's why miles per year. Inches per year. How many inches of corrosion has been spreaded on the metal surface per year? That is IPY, inches per year. So these are some of the units for corrosion expression. Now, pilling bedworth ratio, PBWR. PBWR is nothing but, in corrosion of metals, the pilling bedworth ratio, which is nothing but PB ratio, is the ratio of the volume of the elementary cell of a metal oxide to the volume of the elementary cell of the corresponding metal from which the oxide is created. Now listen carefully. Simply to understand this PBWR, pilling bedworth ratio, for example, you assume there is a metal with X volume. Whatever the corroded part, corrosion occur part of that metal is there, the volume of the corroded part by total volume or total area of that metal is nothing but PBWR. Very simple. The area of corroded part of a metal surface by total area of the metal surface, that is nothing but pilling bedworth ratio, PB ratio. Now corrosion by other gases. We have seen the corrosion by the oxygen. Now let us see corrosion by other gases. What are those gases? Chlorine, sulfur dioxide, sulfur trioxide, hydrogen sulfide, nitrogen oxide, nitrogen dioxide, nitrogen trioxide, etc. Here X represents NO2 or NO3. Okay. So what are the gases here responsible for corrosion other than the oxygen? Chlorine gas, sulfur dioxide, sulfur trioxide, hydrogen sulfide, nitrogen dioxide, nitrogen trioxide. These are the gases responsible for the corrosion. In dry atmosphere, these gases react with metal and form corrosion products which may be protective or non-protective. Dry chlorine reacts with silver and forms AgCl, which is a protective layer. Okay. For example, there is a Ag with chlorine gas. What is forming? AgCl is formed. So chlorine has come contact with the silver, but this is not leading to corrosion. This whatever the chlorine contacted with the silver, that is helping as a protective layer to the silver Ag. Whereas when we talk about this SnCl4, tin tetrachloride, this chlorine is not acting as a protecting layer to tin, Sn. Why? Because it is volatile. That means whatever the chlorine interacted to the tin surface, that will be further damaging the tin surface because of its volatile nature. Okay. In petroleum industries at high temperatures, H2S attacks steel forming ferrous sulfide scale, which is a porous and interferes with normal operations. So now hydrogen sulfide H2S dangerous to metal surfaces because it is forming ferrous sulfide. Ferrous iron comes from the metal or vessel. So hydrogen sulfide, let us see here. So iron, there is a iron means any vessel or anything, iron plus H2S gives rise to FeS. That means this hydrogen sulfide, whatever the sulfur gas is there, that has been interacted with iron pipe or iron metal or iron vessel, and it is forming iron sulfide. Iron sulfide, it is not acting as a protecting layer. Sulfur is degrading the iron. Okay, that's the main disadvantage here. हाइड्रोजन सल्फाइड में से सल्फर गैस इनसे रीच करके मेटल को डिग्रेड कर रहा है. इट इज रेदर देन प्रोटेक्टिंग लाइक AgCl, it is degrading the iron surface. Okay. Now third one is liquid metal corrosion. Liquid metal is nothing but molten metal. For example, if we heat aluminum at high temperatures more than 150 degrees centigrade, what will happen? All the aluminum utensils or aluminum wires will be becoming liquidous aluminum. That liquidous aluminum is nothing but molten aluminum, liquid form of aluminum. So this liquid form of aluminum will be pumped through the pipes, and whatever the manufacturing defects or internal penetration of this molten or liquidous aluminum going into hairy cracks or minute holes of these pipes, and that will be leading to the corrosion. Very simple. Any metal upon heating at high temperature, that will be converted into liquid metal. Once that liquid metal is converted, it will be pumped through the pipes, and if those pipes are having any minute manufacturing defects like cracks, voids, okay, holes, this liquid metal will be occupying those cavities, and ultimately this liquid metal will be leading to the corrosion at that void or crack or pit or damage. That kind of damage is nothing but liquid metal corrosion. Okay. For example, liquid mercury dissolves most metals by forming amalgams, zinc amalgam, thereby corroding them. Okay. Example, best example, mercury. Mercury is the liquid metal. When we are pumping this, it will be deposited to zinc pipes, and finally it will leads to the corrosion. So this is the liquid metal corrosion, which is a dry corrosion. Why? Because there is no direct oxygen or atmospheric moisture contact with metal. Now types of corrosion: galvanic corrosion, waterline corrosion, pitting corrosion. Now let us see. Galvanic corrosion is nothing but wet corrosion. Wet corrosion is nothing but electrochemical corrosion. This type of corrosion occurs when the metal comes in contact with conducting liquid, or when two dissimilar metals are immersed or dipped partly in a solution. Now let us see here. There is a brass made bolt, and there is a steel. Steel is nothing but iron and carbon. Nut made of iron and carbon, that is steel. and here brass, which is nothing but copper and tin. So there are two dissimilar metals here, iron nut and brass bolt. So since there is a iron nut which goes fastly under the oxidation at atmospheric conditions like oxygen and water, or humidified moisture conditions, it goes oxidation. Oxidation is nothing but Fe gives rise to Fe 2 plus 2 electrons. This whatever the 2 electrons ejected at the oxidation, this will be reaching to the cathodic part, that is nothing but brass, and reduction takes place at the brass and nut wherever they are in the close contact. So oxidation at the nut iron part, reduction at the brass, that is nothing but cathodic part. Finally, with the help of atmospheric oxygen and moisture, this electron exchange takes place from the anode to cathode and leads to the corrosion. So that is why we are calling it as a wet corrosion, or galvanic, or electrochemical corrosion. Why? Because एनोडिक पार्ट पे ऑक्सीडेशन हो रहा है, ऑक्सीडेशन में इलेक्ट्रॉन रिलीज हो रहा है, दैट इलेक्ट्रॉन इज रीचिंग टू द कैथोडिक पार्ट एंड कैथोडिक पार्ट पे रिडक्शन, दैट इज नथिंग बट गेन ऑफ इलेक्ट्रॉन, and finally corrosion will be initiated. So here atmospheric oxygen and moisture are acting as electrolyte, or medium. That is why electrochemical, or wet chemical, or galvanic corrosion we are calling it. Now mechanism of electrochemical corrosion. Galvanic cells are set up between dissimilar metals in contact with each other between dissimilar parts of the same metal when surrounded by moist and liquid. Yes, as I said, moisture and oxygen, atmospheric oxygen. What's happening? Here you can see reaction at anode, iron goes at oxidation, Fe gives rise to Fe 2 plus and 2 electrons, loss of electron. Reaction at cathode, oxygen, atmospheric moisture, and this electron gained here followed by the OH minus ion, hydroxyl ion, that is reduction, gain of electron. Net reaction, iron plus oxygen plus water gives rise to ferrous hydroxide, FeOH, as we have seen earlier. This ferrous hydroxide further dissociated into Fe2O3 N2H2O, that is nothing but rust or corrosion. Rust or corrosion. Okay, you can see here anodic part, oxidation, electron release hua, this electron is going to cathodic part with the help of atmospheric moisture, and then finally rust, followed by these three reactions. Okay, now major differences between dry and wet corrosion. Dry corrosion occurs in the absence of moisture. What are the responsible for the dry corrosion? Oxygen, other than oxygen like chlorine, hydrogen sulfide, hydrogen sulfur dioxide, sulfur trioxide, etc. Here corrosion occurs in the presence of conducting medium, that is mainly water, wet water, or atmospheric moisture. Okay. Now it involves direct attack of chemicals on the metal surface. It involves formation of electrochemical cells, oxidation, reduction. Okay. The dry corrosion is slow, whereas wet corrosion is a rapid process, faster. Corrosion products are produced at the site of corrosion. Corrosion products occur at anode, but rust is deposited at cathode. The process of corrosion is uniform, whereas in the dry corrosion, whereas in the wet corrosion, It depends on the size of the anodic part of the metal. Okay, these are the major differences between dry and wet corrosion. Now, final part of this corrosion is pitting corrosion. Pitting corrosion is nothing but localized corrosion, or localized attack in the metal, resulting in the formation of a pit. Pit is nothing but hole or cavity. Reason for this cause, when the anodic area is small, cathodic area is large, it leads to the drastic corrosion at the anode to form a pit or hole or cavity. Okay, we can try to understand it. Here there is a metal, this is the cavity. So whatever the oxygen, atmospheric oxygen or moisture entering into this pit or cavity or hole, it won't be escaped easily. Why? Because it is localized into, it is fixed into this cavity. Okay, that is why this pitting corrosion is called as a localized corrosion. Localized corrosion. Why? Whatever the oxygen entering into this or moisture entering into this cavity, that will further leading to the oxidation. You can see here. Iron gives rise to Fe2 plus and 2 electrons, oxidation. Why? Because oxygen is sitting into the cavity, or moisture is sitting into this cavity, and finally it is leading to the oxidation. Oxidation is nothing but loss of electron. This electron further reacting with cathodic part and leading to the reduction, followed by the corrosion at the pit portion or cavity part or hole part. Okay. Let us stop here. Next class we will discuss about the factors affecting the corrosion, and with that we can wind up our second module, that is nothing but battery chemistry and corrosion. Okay, thank you.